Hey, so in this lecture I want to discuss some programming principles. In future lessons we'll discuss a couple more programming principles, but I just want to get started here with a couple of introductory ones here. The first one that I want to discuss is called DRY, for don't repeat yourself. We have discussed this to some extent, but basically what we want to do is we want to avoid a repetition, and we can do this by refactoring repetitive code into functions or other abstractions, into structs or classes, as we'll see in the module C++ 102. Refactoring is basically the process of reworking a repetitive chunk of code into a function, a reusable function. Typically, if a section of code is repeated twice, then that is fine, but if it is repeated more than twice, then you really want to think about how you can maybe wrap that into a reusable function instead. The next principle I want to talk about is the KISS principle, so keep it simple, stupid. The idea with this principle is to avoid unnecessary complexity. You want to determine the simplest implementation. This is also something that I'll reiterate as we go along throughout future lessons. Basically, you want your code to be self-documenting so that it is easy to read and understand. A couple of examples on how this can be achieved is to use logical identifier names and comments. Now, identifiers can be function names, variable names, and as we'll see in C++ 102, structs and classes as well. As I mentioned, simple code is often self-documenting, so you don't even have to comment it in many cases. And it's also easier and faster to maintain or modify simple code. That's important because being able to modify code quickly often makes the difference between whether a feature will get implemented on time or not, and also whether you'll have a bunch of old code stacking up that'll bog down your project over time. You also have the YAGNI principle. You aren't going to need it. Basically, with this, we only want to implement functionality when we need it. You don't want to implement functionality based on what you think you might need 2 months from now. You want to implement functionality as and when you need it. Otherwise, typically when you get to the code that you've implemented ahead of time, that code is outdated and you have to modify that anyway to fit with the rest of the project. So again, only implement functionality as and when you need it. These programming principles are also referred to as designer principles. Stop eating yourself. And this is just a silly one that I've added here myself out of my personal experience. Basically, you don't want to spend too much time on the same problem. You want to take a break, reflect, and come back to the problem a bit later. So in other words, sleep on it. It's best maybe to work on something else for a bit and come back to the particular problem later on. It's almost when you try to force yourself to remember someone's name or some particular thing's name. Doing that makes it even worse. It typically comes back to you a bit later on. This can be applied to solving problems in general, so it is typically when you take a break when fresh ideas come to mind. To wrap up this lecture, as I mentioned, I will be discussing additional programming principles in upcoming lessons. These are just a couple of ideas to help you out when debugging your programs and solving problems in general. But I'd also like to mention that you should balance the programming principles that I mentioned. For example, with the DRY principle, don't repeat yourself. It's often the case that when some students see some particular piece of code being replicated, that they go and wrap that up into a function, and then with that they have a loop in there and stuff like that. That is when it is often not necessary to do that, and that is basically going against keeping it simple. So there is a bit of a balancing act with this, and I may discuss this in a bit more detail again in the module C++ 102. There is some overhead involved with calling functions, so you don't want to wrap everything up into functions. In some cases it's fine to have some repetition, so again, don't overcomplicate stuff. And when in doubt, go and ask a senior programmer in your organization or your company, or refer to the company conventions. So with this, we are going to wrap up this lecture. I'll see you next time.